So it's February 15th. We are doing another online meeting. Yesterday at Lamar, we were able to get the drivetrain assembled and actually moving, which is a big accomplishment because we were struggling with one swerve drive module. So we had 3 out of 4, but I think we finally got the fix and the code worked. So now we're going to just slowly start adding things to the code and subsystems to get more pieces working. And then the shooter plates came together and we did some testing on those. Both of the climber and the boxes were put together mostly, and those can be set up for testing soon. And yeah, so we're making good progress. We just got a lot of work to do to clean it all up. So with that, I think we're going to let Cedric talk about the CAD, and this is kind of open forum. So if you want to talk about something, feel free to listen in, or just say something, and we'll have a conversation about it. So, Cedric, after you.
Yeah, so Saturday we were able to cut this version of the shooter. The way that it mounts to the drivetrain is we have two pieces of max tube down at the bottom, and the whole idea is we can rivet these or attach these plates to the max tube and then do a combination of fasteners to secure the max tube to the drivetrain or the belly pan. And so it's 6.5 inches wide, and I have this with me at my house. Basically, it's a pretty relatively standard sort of shooter, tall shooter. We have these churros here along the back, and we added a black. I'm pretty sure it's like an ABS sheet that's a 16th inch. Yeah, so we added that and then added zip ties to create that curve. And then this uses a 3-inch Coulson, two 3-inch Coulsons that run on a Neo. Yesterday, when I was designing it, I didn't realize we didn't have the belts that this was designed for. So we weren't able to get it exactly right, but we were able to find a compromise. And basically, we spun the flywheel faster than the motor was spinning using belts and a tensioner. I don't think we got a 100% shot in quite yet, because I think stuff started breaking because we had to use a plastic pulley because this is the closest thing we had at the top, and so it kind of broke before we got a chance to go at 100. But from what we saw, it was by far the most promising test that we've seen compared to our other two versions. So with that, I have started working on the next iteration that uses the more common belts that we have. It's honestly pretty similar. Carl also found 4-inch Coulsons, and I thought that might be a better way to get surface speed compared to the 3-inch ones. I have 3 of the 4-inch Coulsons that are seen here. They're a bit tough to get on the shaft, but I think it's worth it to try it. The compression number is still the same, so that geometry didn't really change. But yeah, the wheel is bigger. The rollers changed a little bit in position, but I don't think it's enough to really make a huge difference in performance, because I mean, when we tested the indexer, we were pretty happy with it. It worked pretty well. Shooter was able to shoot okay. Still not quite the performance that we need, but again, that was in one Neo running at I think we got to 50 or 70 before stuff started shredding. So yeah, this hood design also stayed basically the same.
Question.
Yeah.
Why not just increase the speed from the Neo instead of changing the wheel size?
Well, I think we're gonna modify the wheel speed with the Neo anyway. But I think while we have 4-inch wheels, I think we might as well use them. Just because it'll just give us more surface speed. So if we decide we don't want to overdrive the Neo, then we don't necessarily have to.
So are we just changing the hood? Is that how we accommodate the compression of changing the wheel size?
No, the way that I had it set up in my sketch, I could change the diameter of our wheel, and it would auto adjust the rest of the dimensions to slide around.
But that
So yeah,
means
I mean,
making we can't use the plates we made on
no,
4-inch wheels.
yeah. Well, I was under the impression that because of the whole belt situation, we were just recut new plates anyway. So that's what I had in mind trying with this design.
Okay. I mean, 4 inches is possible, but um, uh, I don't think it's going to make that much of a difference between a 3-inch wheel and a 4-inch wheel. I guess is what
Okay.
I'm trying to say. So just, but okay, yeah, continue. Sorry.
Okay. So yeah, we have that going. The hood is basically the same. I think I added lots of tolerance between like churros and stuff because that was an issue on this iteration. Um, yeah, the hood is still going to be actuated by a motor over here via dead axle that runs on the flywheel shaft. The another issue that we saw with this shooter is that in its current state, it would cut into the indexer by a lot. So what I did on this one is made two different plates, and one has this big cutout that you see here. And so if you look on the robot, let's hide this for now. If you look on the robot side of things, it no longer interferes with the indexer. So we because this would have been a whole wall, and we thought that that would be an issue. So yeah, I just cut that out. We would probably need some more support that comes from the side because this may not be enough attachment points. We can always add holes down here, but it's still not going to make a big enough of a difference. So we will probably need to figure out some sort of brace or something to make sure this doesn't really flop. I also changed the plate thicknesses to what I think is going to be closer to what we do, which is 1/8 inch aluminum for most of these components. I mean, it's a minor detail now. It didn't really change any of the geometry at all. Yeah, this I also worked on this climber mounting. This was previously a 1x1 down here, but we realized we could do a 2x1. We just need to change sort of the configuration of change the position of the churros on the spindexer, which isn't a huge deal. I think the bigger issue is this issue with the interference. So it's something I need to look at better. It's not completely solved yet. So I'll have a look at this soon and try to find the geometry that allows us to do what we want. We also looked at this climber plate here. This is just a nice and simple like plate. We have a max tube 1x1 that goes across, and then we would just mount this plate straight between the climbers, and then it would let us climb. Yeah, we didn't get a cut. I think the only thing we got cut on yesterday was just the shooter stuff. But yeah, when we have time, we can always cut whatever else we need. I just need to have a better look at the climber and whatnot. So yeah, that's update so far.
For the climber, Levi and I were talking about it yesterday. Uh, it's possible we might want to make the two plates like a little different heights since we're coming at an angle.
Yeah.
So it's something we should think about. I think we should also add more holes because if we want to add like a traction surface, let's say we wrap like some foam mesh, having some more holes that we could maybe zip tie a foam mesh that'll give it grip when it holds on the bar. We could just wrap it around that edge and zip tie it in. Does that make sense, Levi?
Yeah.
Yeah. Because we don't want it to slide, and it's a steel on steel surface, so we need to have some more friction somehow to get it to hold. Mm-hmm. I guess we could also like 3D print something in there that has some grip too. So Um, for the shooter plates, I like that standoff you have in the front. You could just add another one of those to brace it up more.
Are we talking about this one?
Yeah,
Just add two.
yeah. Put another one further down, closer,
Okay.
closer to where the motor
Yeah.
shaft comes to that last indexing wheel.
Right. Okay.
I know we can't put one inside of there because we got stuff happening, but if we, thinking about places we could put it where it doesn't interfere with the ball. So,
Yeah.
are we happy with the location of the shooter? Like, do we want to move it over any direction, or is that seems reasonable with the Spindexer?
Yeah. I mean, I positioned the shooter based on where the Spindexer was, because the way I thought of it was the Spindexer, we were pretty high. Yeah, it has some things that we need to tweak. But I think it's probably the most complete system that we have so far. So I based this shooter based on where can I put it in relation to the indexer to make it work. So
If you have some extra gap room, you could have the shooter hang over the edge of the frame.
I think parts of it are already hanging over the edge here. Um,
Okay.
I did have a look at that, but I think because of the way it's sloped, it's already basically at the edge. I think there's maybe a couple inches there, but it's not much.
I know you were trying to get another inch for the Spindexer, so that's why I was suggesting you might
Yeah.
need some space there.
Yeah.
I honestly think the Spindexer might be too large, if that makes any sense. You have
So
some
we're
wiggle
thinking
room.
of smaller diameter.
Yeah, I think the circle might just be too big, but I don't know. It's just me eyeballing it. You'd have to look at the actual dimensions.
Yeah. We may also test brushes again if we want to do higher walls, because I know we tested with the flywheel and that worked, or with the flex wheel and that worked better. Um, but depending on how we want to do it, we could try the brushes again with higher walls to see if it works better. But I don't know. I think with the flex wheels, we could technically do a smaller diameter and make it work. I don't know if that can be said with the brushes.
Yeah, I'm thinking about how you make space for the climber. So technically, we don't need the 1 by 1.5, if that makes sense. So we could potentially change some geometry there.
Do you mean like move it closer to the
Yeah,
winch?
yeah. Because if you have a 2 by 1 plate there, or 2 by 1 bar coming through, the 1.5 by 1 is not that necessary if you put gussets that brace both ends of those plates to the 2 by 1, if that makes sense. So
Yeah.
it's just extra space. I mean, it's a little more complicated, like bracing, but it should help you eliminate like an inch, I think, from that if you try to brace it differently without using 1.5.
Yeah. How
Just
would we connect a gusset to that though?
um, well, this might be like a more complex part, but imagine if we just had a piece of angle, and let's say it's like a large angle, like a 2 inch angle, and then
Oh, and
we
yeah. Okay.
and then
And
we
use
like
it.
CNC both sides of that angle to have the right mounting pattern so it just lines up between the 2 by 1 and the plate.
Yeah.
So then it'll stiffen everything up and you don't need the extra 1 inch of space you have there.
Yeah.
Might be one we ask for help on if
Yeah.
we want to ask Spectrum for some help. That might be a part that they could assist us with. So.
I think we should also consider like testing out one of these plates by cutting them, because I will say I did move to try to make it as compact as possible. I did move the location of the winch closer to the tube. Now, to my knowledge, it shouldn't really affect things that much. Um, but I don't know. It's just something that I like. I've had experience like copying geometry, but changing things slightly and it not working like I intended it to. Um, so it may be something we want to try to cut these plates and see if this angled mounting works. See if the winch is in an okay spot and stuff like that.
I think that's fine. Yeah, I mean, even if we're a little oversized, we can kind of make it work. As long as it all tests out correctly, then we can try to make it more compact later. But if we can get it all to fit in CAD now, even better. I mean, look, yeah, I think that's a simple solution to eliminate 1 inch. That should help you, and then we could also just move the spindexer higher if you wanted to put things up. But honestly, I don't even know why. Why does this whole plate need to be? Why does the climber plate need to be above that 2x1? You have it in the back there, but I don't understand why.
I think I was trying to do something with the shape of this, but yeah, I didn't really think of that. I guess I could just make it smaller.
That might be the simplest solution.
Yeah. Okay. Yeah.
And
Okay.
then you don't have to do anything. You can just keep it all the same and just cut that plate
Yeah.
down. So
Yeah. I don't know why I didn't think of that. That makes sense.
let's talk bumpers. I'm
Yeah.
I was talking to Levi yesterday about bumpers, and I was like, man, maybe we should think about those C bumpers again instead of doing a full surrounding bumper. I'm worried about like what happens when the intake is down or the climber is extended and we can't get the climber to go down, and then we're trying to get these bumpers on and it's like something's not quite fitting in perimeter and then we can't get the bumper on, if that makes sense, or it just makes it a lot harder to put on. So what do you guys think about C bumpers versus a full one piece bumper?
I don't know. I'm not really against the idea. I think that might just make things a little bit complicated when it comes to like where do we put the latches? Because I would assume we discussed this last year. If we want to use these sort of latches, it has to basically be a one piece bumper, or not. When we put it on, it'll just wobble. And if we were to make a cutout right here for the, because I would assume the cutouts for the climber, right?
Yeah.
Okay. We would need a, yeah, it would just be a bit tough. There's nothing that says we can't do it, because I think that's true. We're gonna have so many tall things close to the frame perimeter, it may make bumpers annoying to swap and stuff. So I'm not against it. It can just make sorting out these latches and strikers a bit more complicated, but we can do it probably.
We might have to have something a little different on the very edges, if we can't fit the strikers in. So let's say we have strikers on the nice, long parts of the bumper, and then we might have some other assembly method that's on the very edges that's a little bit more compact. So
I mean, if we had to
used before, I mean, I don't know how much you've looked at the other bumpers, but we basically just have screws that go through holes.
Yeah, I mean, worst comes to worst, we could just do bumper studs on the corners.
That's what I'm thinking is we might have to
Yeah.
change that mounting system because I think you're right. I think putting the strikers on the very edge, if we have a well, we'll see. I mean, there still might be some room there, but it's going to be tight. So
Yeah. Because I think if we were to make a cutout right here, you'd ideally have two strikers on this one side, but that would be complicated over here with the intake. So yeah, we could also do. I think it wasn't really good, but on crescendo we had screws coming from the bumpers and then nuts that were on the other side. That might be the way to go for this corner if we were desperate. But yeah,
yeah, I
just
think one
don't.
option will be we might have to just have some sort of we might have to cut open a little section of that if we really need to. But this is just something we need to model. Um, so if Levi is done with the climber stuff, I recommend you start thinking about bumper latching because we need somebody to sit around and just think about the locations of where these bumper pieces will go so we can start cutting the wood parts of the bumper and just test with pieces of wood to see what we like. Does that make sense, Levi?
Yes, sir.
Okay. The other thing we don't have any details on is electronics. It might be helpful for Ethan to give him some ideas of where things are going to go so he can start making sure the wires fit in the right locations.
Yeah, it's just tough because my plan was to put electronics on the walls of the hopper just because it would be outward facing, it would be open, and so if we ever had electrical issues, it wouldn't be difficult compared to like where I had it previously, which was under the spindexer. It would have been basically impossible to reach to if we had issues. So yeah, that's my main concern with electronics right now is just
Just,
where do we put it?
I would say assume that the spindexer can just come off because it's taking up so much space. Like there might have to be times where we need to just take it off and go
Okay.
look at something, right? Because it's got the way it's mounted. There's what four bolts that would attach it to the frame.
Oh yeah, up to 6.
Yeah, and then the whole spindexer technically could just kind of slide out.
Yeah, that's the idea.
So why don't you experiment by putting the PDH under the spindexer and find a position that is somewhat reasonable, and Ethan can experiment with trying to keep it there based off what we have right now, and if we decide we really have to move it, then we'll move it. But that would be my first vote for the PDH and a lot of the other wires. Just keep them low.
Okay.
Now
Yeah.
the Rio, I agree, it might not fit well because we actually have to plug things in and look at it. So hopper panels or some sideways condition for the Rio, but the Rio's got the Navex on it, so we gotta be a little careful about where we put it. It could be up somewhere high. I mean, it could be like above the climber winch or something. That makes sense in that open space there.
Yeah.
And then we put because we'll probably have some the way all the balls will funnel. We'll have some gap space there to put stuff, like the Rio and maybe the radio can go up somewhere too.
Yeah. I mean, another candidate was somewhere in this corner because I think that's the most open space on our robot. Is this corner over here? Um,
My,
so that could
my
be an
vote is the
option.
PDH goes there.
Yeah. Yeah. I can try something like that.
And then we could just put some holes through that 2x1 so we can run
For
wires
wires.
through there. Yeah. But yeah, if you could give like a rough idea of what would fit, that way Ethan can start putting things in a rough location on the practice robot and trying to fit all the motor controllers and stuff around that. So
Yeah. Okay.